And I think with that, Eric's going to describe a bit more of the outputs and the benchmark results.
Cool. Yeah, so you talked about it real quick. So the output, really there's going to be two outputs. We generate a quick HTML report so that you can view the results in the web browser. But I think the more important one would be the actual raw data. So it's like your HST or HLN, TF2 files. It's pretty easy to download them. There's just a button that you press download and it downloads it. Pretty nice. And then from that file, you can load those into any of your 3DCS software, so your Multicad, V5, whatever, and view the results and see what's going on, just like you normally would.
And create your reports, which will now be available in PowerPoint and
Exactly.
Word and Excel, straight out of 3DCS using that data.
Yeah, I'd like to interject here too. This is DJ again from Ag. I'll just confirm that it's been very simple to use and learn. So the interface has been built by Matthew and his team to be quite simple. So very nice. We appreciate that from an end user.
Yeah, that's the goal. Making them accessible.
So like we said, we went through a couple benchmarks and we got some pretty good results. So if you kind of see, we've got your one thread is in blue, 4 threads is in orange, and you kind of see that as you increase the concurrency, so the number of essential computers that you're running on the cloud, you'll see the time to finish decrease quite rapidly.
So just to interject for 1 second. So the reason this is important is because the framework of using the ParallelWorks distributed memory is a credit system based on how many hours you use on how many machines. So if you've got a small job, you can just use a couple additional machines on the cloud, speed it up, or if you have a very large job, you can crank it up as high as you want. So you can control how much computing power you want to use for it based on your exact job.
Exactly, right. Like if you're trying to run a huge job, then you can just throw more computers at it.
Yep. And I just wanted to add on that front too. The last slide was showing actual individual model results. Running at one computer, 10 computers, and 30 computers. So that x-axis is like number of computers that are used to solve the problem. And you'll see like there's significant speed ups on them, kind of an individual run level. But a kind of another cool point is I just wanted to stress the concurrency of being able to run multiple jobs at the same time. So we actually ran all these benchmark studies at the exact same time and finished them. We didn't have to wait sequentially for each one to finish. So we ran, I think, about 18 benchmark runs here, I think, and all those were executed in parallel. So, and about 250 to 300 Windows machines.
So a quick follow-up on that. So since we're talking so much about speed here, if I just, instead of using distributed memory, I'm just going to be using the shared memory, and I go from 1 to 4 threads, how does that affect my machine itself? Am I using up a lot more of my machine's resources then?
Yeah, essentially. Yeah, you're going to be taxing the machine more. So if you have 4 logical processors and you try and use all 4 of them, it's going to slow your machine down quite a lot. If you have some really impressive machine and have 8 or something like that, then you'll notice that there is some slowdown, but it won't probably impede you too much. And similarly, if you have a 4 logical processor machine and you only set it to 2 threads, you'll still be able to probably do stuff like emails and stuff. But you will notice that the machine is using more resources to solve the problem.
And this is, of course, available on all of our 3DCS platforms. So whether you're using it integrated in CATIA, we're using our Multicad, our NX, or our Creo, you can take advantage of both of these features. Of course, the shared memory is going to be baked into 3DCS, while the distributed memory does not require an add-on license or any additional licensing. All you have to do is, it's kind of like a pay-per-use model that we'll get to a little bit later on.
Yeah, so for that, if you're using a different platform, so like V5, to upload your model to Parallelworks, you have to export a WPX. So that is one thing, you know,
Okay.
pretty easy to do, but you do have to use WPX files. So this is essentially the same results, just kind of shown a little bit differently. And it does show the drastic decline in the amount of time taken. And it kind of shows that the more computers that you throw at it and the more threads that you throw at it, the faster it's going to get, essentially. And it, you know, it's one of those where we go from 16 all the way down to, you know, minutes.
Yeah, so that's 16 over there on the left. That's hours. So you can see on Model 4, what originally took 16 hours to run a simulation, just without even using the distributed memory, just on your existing machine, we see a drastic, almost 75% reduction in analysis time. Then, if you know it's going to still take you 4 or 5 hours and it's the beginning of the workday, you can use your distributed memory to pass it off to the cloud to run your analysis while you go about your normal day, and you're getting another 50% increase in speed on top of that.
Yeah,
or
yeah.
2 times increase in speed.
Yeah, and you can, like I said, you can go all the way to like 30 concurrent. You see it's, you know, only taking
30 minutes, 20 minutes?
Yeah, less than that.
So down 16 hours down to 15 minutes.
Something like that, yeah. Pretty fast.
Is it okay to go back one slide,
Yeah.
if you don't mind? One question I wanted to ask is, you can see that the number of processors you add, like from 10 to 30, that the improvement, you know, starts to diminish.
Right.
Is there ultimately going to be a button that says, hey, check out my model and I should use so many processors? To try to predict, you know, should I use 10 processors or should I use 100? Or should I pick 100 and I only need a 10?
So this is a function of how many samples you're running. We didn't give a lot of detail in these models, but some of these models, we're only running 500 samples. We're not even running, you know, 2,000 or 5,000 samples. So it's a function of how many samples you're running for simulation and the time of every single build. So there is a sweet spot for these models that you're going to have to figure out, but it has to do with that. And all we're talking about here today so far is really simulation, right?
Right.
We're also doing this exact same thing, this exact same result we should expect from simulation or sensitivity or simulation-based sensitivity. We're going to get these same types of improvements. So,
Yeah, because if I'm looking at that graph up there on the screen, it's like, well, I don't ever have to go past 10. You know, that gives me the drastic improvement.
Yeah. I mean, there's definitely a point of diminishing
Returns.
but that is kind of.
We don't know. Yeah, we don't have a way of telling you at this moment.
No.
Okay,
no,
that's what I was wondering.
Yeah, I mean.
Well, as a rule of thumb, generally, I mean, just looking at your results here, judging by the size of the model you have and the amount of runs you want to do, you're going to want to pick, 10, 30, 50 concurrents. So if you're running a finite element analysis model, a compliant modeler, you want 10,000 samples. You've got, 3 or 4 parts in it that have compliancy on it, and you've got, feature measures and some of these iteration moves on it. You're going to need to crank it all the way up to the top. But if you've got a model that normally takes you 4 or 5 hours, you don't need to crank it that high. So some of it's going to be a little bit user-based on what it is you want.
Is there a way, you know how when we run the simulation, we give you a time bar? And I apologize, I'm asking these questions. Can I go to the web and say, okay, 10 processors, and it gives me a time bar and says 15 hours, and say, okay, wait, 20 processors, and then it gives me a time bar and says 1 hour, before I actually push the button?
No, I don't think we really have anything set up to do that. It's a good idea. Maybe we'll try and look into.
At the moment, not. But I could see like a little pre-step of the workflow that would run and just do a little get the build time or something, or estimate build time and then extrapolate it out.
Okay, sorry
Yeah.
for the sidebar.
No, that's fine. And on that same thing, the runtime, you'll know that when you run shared memory, you'll see that it actually is quite a bit faster when you run 4 threads versus what you were running before.
Well,
You'll
right.
actually see it updating. If you'd ran the model before, you run it now.
Right, I've done that. I've done that with my models where I started to run it, and after about 10 simulations, it says 10 minutes.
Right.
And I cancel, and then I set it to 4 threads, and I run the simulation, and then it says 2 minutes.
Yeah.
And that's kind of what it's like. Okay, I didn't waste a whole lot of time figuring out I better go with some more threads.
So this is just kind of encapsulating what we've been showing with those models, actual amount of data that you see. So you see that if we just run your normal computer shared memory 4 threads, you'll get 3 to 4 times faster is what we're seeing. And then if we crank it all the way up to 30 concurrent machines on the cloud, all using 4 threads, it's getting closer to 50 times faster, which is pretty good.
It's very significant.
It's amazing.
Yeah. So I guess we can just go over what's currently working and what we're planning on implementing. So essentially we've got the 3DCS graphical interface. We've also got the batch processor, also called SimiMacro. And then we've got the 3DCS ParallelWorks, which is integrated into your web browser. So Monte Carlo simulation, HLM sensitivity, geofactor, these are supported everywhere. The AAO geofactor analyzer is still being planned to implement in the batch processor. And once it's implemented there, we'll be able to put it up on the web for ParallelWorks. AAO's simulation-based sensitivity is implemented, which is one of our new things that I think we had a webinar on just a little while ago. And like I said, that's fully implemented even on ParallelWorks. We're working on getting the worst-case analysis into batch processor and in ParallelWorks, and we also have design of experiments, so DOE, in the process of being worked on.
So one thing to point out here, simulation-based sensitivity. So as Eric mentioned, the last webinar we did was on simulation-based sensitivity. You can find it on demand. And simulation-based sensitivity is going to increase the time of your analysis a great deal because it's a much, much more detailed sensitivity analysis. So that is also one of the driving factors for us trying to increase the speed of your analysis time. With the ability to do shared memory and distributed memory, you're not going to see a huge increase in the amount of time it's going to take you to get your results, but you can get more accurate and powerful results, especially for nonlinear models and models that have mean shift.
Yeah, that's really important. This is DJ again. I just wanted to reiterate here what Matthew had touched on too, the ability for us to actually run all these simultaneously as well. Our simulation, our geofactor, sensitivity, all running at the same time and getting results back instead of having to do it serially like before is huge. So those time improvements as well as running them simultaneously in the cloud solution, that's pretty awesome.